Hey my dear data friends, it's Nicola from Data Mozart. Are you ready to take your Microsoft Fabric skills to the next level? In the next approximately 1 hour, I'll introduce you to all the core components and all the key features of Microsoft Fabric. After watching this video, I hope you will feel more confident diving deeper into more advanced Microsoft Fabric concepts and capabilities. So relax, take some refreshment, and enjoy Microsoft Fabric, the ultimate guide for 2025. So let's first understand what are we covering today in this video. First, I'll explain what Microsoft Fabric is and in which scenarios you want to consider Microsoft Fabric as a possible solution. Then we'll talk about what makes Microsoft Fabric a unique proposition for your business. Then we'll understand each and every component, or let's say core components of Microsoft Fabric, and we will wrap it up by talking about the licensing for Microsoft Fabric and next steps and learning resources that you can use to deepen and sharpen your knowledge about Microsoft Fabric. The illustration you see on your screen is the best possible explanation of why Microsoft Fabric was born. Now, you are probably searching for the Fabric icon in this chaotic illustration, but no, don't do that. This is the illustration taken from Matt Turk's website, so credit goes to him. The illustration shows all, or let's say almost all, services, tools and offerings in the data and AI landscape. Is it overwhelming? Sure it is. Is it easy to get lost? Oh, absolutely. And what is the worst thing? You can pick the best in-class solution for a specific task or topic. Think of data ingestion, data management or data governance, and still end up having a disintegrated and disparate data platform as a whole. And here is where Microsoft Fabric kicks in, offering an end-to-end analytics solution under one single umbrella. Is it the best possible solution for every single aspect of the data platform architecture? Probably not. But in the end, a team wins the game, not individuals. More on that team analogy in a few seconds. And when I say analogy, I'll start with analogy. I'm a huge football or soccer fan if you prefer, if you live in the USA. So in a football team, you have players with different characteristics, playing in different positions, having different sets of skills. For example, you have very fast players who can play on wings and utilize their speed to create chances for the team. Then you have strong and tireless players who can excel in defense. You need a goalkeeper as well as players who are skilled to score goals. Now imagine yourself being a coach of this team. So you have all these players at your disposal and your task is to establish the system that best fits your players, with winning the match as the ultimate goal. Think of Fabric as the data football team. Microsoft provides you with the players, and your task is to integrate these players into the system that will ensure success. These players are already well-known, seasoned stars, such as Azure Data Factory, Azure Synapse Analytics, Power BI or Azure Data Explorer. But there are also some fresh faces, newcomers that should bring fresh blood to our experienced team. We'll examine most of these players in this video. At this moment, it's important to understand that Microsoft Fabric is not some new fancy tool. It's a suite of individual analytic tools and services that work in synergy to provide a unified analytics experience. What does unified mean in the context of Microsoft Fabric? We already mentioned it's about a unified experience. Whether you look at a single workspace experience, single sign-on experience, single storage format, all the way to single experience for managing security and collaboration. What are the key pillars of Microsoft Fabric? Everything as a service. Simply said, it just works. You don't need to care about the hardware, infrastructure or complex administration. By taking advantage of the instant provisioning and straightforward onboarding, the focus can be shifted to the data analysis itself, ensuring that business can quickly get results. In this scenario, the integration and optimization happen automatically. Centralized administration. The idea is to govern one tenant which contains all organizational data artifacts. So various data professionals across the organization don't need to worry about security or compliance challenges, because everything is handled in one place. Lake, lake, lake. Data lake is at the core and center of the Microsoft Fabric. And since we are talking about the unified experience, how would that experience work without the unified lake? Or OneLake if you prefer that name, and OneLake that we are going to examine in just a few minutes. Let's break down some of the key terms that you will hear when working with Microsoft Fabric. And I thought it would make sense to structure this part hierarchically, so we'll kick it off from the highest level, which is a Fabric tenant. A Fabric tenant is a dedicated space for organizations to create, store and manage Fabric items. There's often a single instance of Fabric for the organization, and it's aligned with Entra ID directory. The Fabric tenant maps to the root of OneLake and is at the top level of this hierarchy. Capacity is a dedicated set of resources that is available at a given time to be used. A tenant can have one or more capacities associated with it. Capacity defines the ability of a resource to perform an activity or to produce the output. Different items consume different capacity at certain point in time. A domain is a logical grouping of workspaces. Domains are used to organize the items in a way that makes sense for your organization. You can group things together in a way that makes it easier for the right people to have access to the right workspaces. For example, you might have a domain for sales, another domain for marketing, another domain for finance, and so on. A workspace is a collection of items that brings together different functionality in a single tenant. It acts as a container that leverages capacity for the work that is executed and provides controls of who can access the items in it. For example, in a sales workspace, users associated with the sales organization can create a data warehouse, lakehouse, run notebooks, create semantic models, reports, and so on. Fabric items are the building blocks of the entire Fabric platform. Those are the objects that you create and manage in Fabric. There are different types of items, as you will see in this video, such as data warehouses, data pipelines, semantic models, reports, dashboards, and many more. Understanding these Fabric concepts is important because it helps you understand how to manage the Fabric environment and how to navigate between different levels of the Fabric ecosystem. Let's now examine each of the players in Microsoft Fabric platform in more detail. And we'll kick it off by explaining the central storage repository, which is called OneLake. As we already told, Microsoft Fabric was born in an attempt to resolve the challenges of multiple siloed data lakes with lots of duplication. No matter which path you take, the results are almost always the same. You end up with multiple siloed lakes for different business domains. Then you need to build solutions for breaking down these silos. This usually involves moving the data. Even after moving the data, most users and applications are not able to access data directly. And that's where OneLake concept was introduced. OneLake represents a central storage repository for the entire organization. Do you know what is OneDrive? Of course you do. Think of OneLake as OneDrive for all your organizational data artifacts. At this moment, please keep in mind that one Fabric tenant includes just one single OneLake. So what is OneLake? Simply said, it's a logical structure of files and folders that may point to disparate data sources. As you can see in this example, OneLake is at the top of this hierarchy. In the illustration on the top, you see all the different workspaces that exist in the Fabric. If you open one of those workspaces, you can see different Fabric items inside, such as data warehouse, lakehouse, GraphQL, Custo database, and many more. And then each of these items, when you open it, contains a bunch of different files. In this case, those are tables, but they are all represented as files in this file and folder structure. With the introduction of OneLake, we have the real separation of compute and storage layer in this architecture. It also means that we create just one copy of the data that can be read by all engines in Fabric. This is a concept that Microsoft calls one copy. One copy aims to get the most value possible out of a single copy of data without data movement or duplication. Thanks to OneCopy, the decision on which engine to use to build your analytics solution can be separated from how that data is going to be consumed and used. It is now a matter of preference. You may have some teams who prefer working with SQL and store procedures to build a data warehouse. If your data engineering teams are more oriented to Spark rather than SQL, they can use the full power of Spark and notebooks to transform and load the data into a lakehouse. Each team can build a solution their way while still all contributing to the same data lake. You know that old saying, all roads lead to Rome, right? In our case, all Fabric roads lead to OneLake. We've already examined the native way in which OneLake stores the data. Now, let me introduce you additional approaches and concepts in Microsoft Fabric that supports the concept of OneCopy. On the left-hand side, you see the concept of mirroring. Mirroring is the feature that enables avoiding creating complex ETL processes. Mirroring allows you to create a real-time replica of the data in Fabric, and this data originally comes from the data sources that are outside of Fabric. Currently, supported data sources for mirroring are Cosmos DB, Azure Databricks, Azure SQL DB, Azure SQL Managed Instance, and Snowflake. Real-time replica will be created in a Delta Parquet format, so all the mirror data can immediately be leveraged together in combination with other Fabric workloads. Now, let me introduce you another brand new approach in Microsoft Fabric, which is called shortcuts. Shortcuts in OneLake allow you to unify your data across domains, across clouds, and across different accounts by creating a single virtual data lake for the entire organization. I like to think about the shortcuts in OneLake similar to shortcuts in Windows File Explorer. You know, there is a file which is stored on your D drive in some subfolder over there. And because you want to quickly access this file, you create a shortcut on your desktop. So the file is still opened directly from its original location, but you can access it directly from your desktop. It's similar in OneLake. Simply said, shortcuts are objects in OneLake that point to other storage location, and this location can be internal or external to OneLake. Shortcuts are independent objects from the target, meaning if you delete a shortcut, the target remains unaffected. How does this concept apply in real life? Let's say I have workspace A with two lakehouses in it, Lakehouse A and Lakehouse B, each of them containing separate tables. Now, if I need to leverage data from table B in my Lakehouse A, I can simply create a shortcut and then use this data as it was natively stored in my Lakehouse A. You are not limited just to a single workspace. In some scenarios, you will have a lakehouse which resides in a different workspace, in this case workspace B. So again, I can create a shortcut to table C from workspace B and again leverage this data together with data that is natively stored in my Lakehouse A. There is no physical data movement, it's just a pointer to the data that is stored in a different location. Let's now start with examining core components of the Fabric platform. And we'll kick it off with Data Factory component, which is used for data ingestion. There are two main items that you are going to work with in Data Factory experience: pipelines and data flows Gen 2. So let's start with pipelines. Pipelines in Microsoft Fabric encapsulate a sequence of activities that perform data movement and processing tasks. You can use a pipeline to define data transformation activities and orchestrate these activities through control flow that manage branching, looping, and other typical processing logic. Let's now examine the core pipeline concepts. If we start with activities, activities are the executable tasks in a pipeline. You can define a flow of activities by connecting them in a sequence. The outcome of a particular activity, which can be a success, failure, or completion, can be used to direct the flow to the next activity in the sequence. There are two broad categories of activity in a pipeline. Data transformation activities. Those are the activities that encapsulate data transfer operations, including simple copy data activities that extract data from a source and load it to a destination, and more complex data flow activities such as data flows Gen 2, for example, that we are going to examine in a few minutes. Control flow activities allow you to implement loops, conditional branching, or manage variable and parameter values. Pipelines also support parameterization, and obviously running a pipeline in a manual way would be a tedious task. Hence, we can schedule the run for the Fabric pipeline. Copy data activity is one of the most common uses of data pipeline, and many pipelines consist of a single copy data activity that is used to ingest data from an external source into Fabric Lakehouse. When you add a copy data activity to a pipeline with a copy data tool, a graphical tool takes you through the steps required to configure the data source and destination for the copy operation. A wide range of source connections is supported, making it possible to ingest data from most common sources. You should use the copy data activity when you need to copy data directly between a supported source and destination without applying any transformations, or when you want to import the raw data and apply transformations in later pipeline activities. I'm at the home page of Microsoft Fabric, and from here I can choose between different experiences. So let's go to Data Factory experience first and create our data pipeline. You can create new item from many different places in Microsoft Web UI, but I will use this top right corner and select Data Pipeline. Let's give it a proper name, something like Fabric Ultimate Guide. As you already learned, Copy Data Assistant gives you a possibility to quickly get up and running and bring data into Fabric. So I'll use this option, Copy Data Assistant. Click on it, and then first I need to choose a data source. There are many data sources provided out of the box to bring the data into Fabric. In this case, let's keep it simple and let's connect to a SQL Server database. So I'll click SQL Server database and provide details for server and database name. Click Next, and now I can choose between different tables that are part of this database. Let's pick DIM customer for example, and click on Next. Now I can load this data into already existing Fabric item, but for the sake of this demo I'll use the new Fabric item and create a new Lakehouse, which will be stored in this DP600 Playground workspace. Let's call this one Fabric Ultimate Guide. That's the name of our Lakehouse. So once I click Create and Connect, we are going to wait for a few minutes, and then we need to map columns from the data source to a Lakehouse table. Since there are no existing tables in our Lakehouse, I will load the data to a new table. Here you can adjust the data types for your columns or get rid of certain columns if you don't need them. I will leave it as it is and click on Next. Now I get the copied activity summary, which says that I am bringing data from SQL Server to Microsoft Fabric Lakehouse. Click Save and Run, and this is now the pipeline canvas. Currently it consists only of one copy data activity, but here I can add additional activities. Some of them can be, for example, a data flow, and then I can connect and say, whenever my copy data activity ends up successfully, I want to run the next activity in the pipeline, which is in this example a data flow. You can also add notebooks and then orchestrate the execution of all the different activities. Finally, if I go to Activities tab on the top, I can also select, for example, Semantic Model Refresh. So once the entire process is completed, I want to refresh my semantic model. So remember, pipelines are used for data orchestration purposes. You see that our copy data activity was successfully executed. So let's go to the Lakehouse and check what happens there. So I'll go to Workspace DP600 Playground. Here is our Fabric Ultimate Guide Lakehouse. Remember, when you create a Lakehouse in Microsoft Fabric, you also get out-of-the-box SQL Analytics endpoint and default semantic model provision. Let's open our Lakehouse and see what we have in there. Here on the left hand side you can see Files area and Tables area. Don't forget, Tables is the managed area of the Lakehouse. So here I have my DIM customer table that we've just ingested from the SQL Server. Next, I want to show you how to create a shortcut to a table from another Lakehouse. I'll hover over the tables and click on three dots. It allows me to choose New Shortcut option. Now I can create both internal and external shortcuts. In this case, I'll create internal shortcut that points to another location within my Microsoft Fabric tenant. So I'll go and choose, for example, this DP600 Bootcamp Lakehouse. Click on Next, and then from tables, let's see what's in there. Let's take our dim date, dim product and fact internet sales tables from this DP600 Bootcamp Lakehouse and create shortcuts to these tables. Once it's done, I have these three tables as shortcuts in my Fabric Ultimate Guide Lakehouse, and from here I can use them the same way as they were natively stored in this Fabric Ultimate Guide Lakehouse. So this is very cool concept, how to leverage shortcuts and combine them with data that is already stored without physically moving the data from another location. Let's now talk about Dataflows Gen 2. Dataflows Gen 2 enables you to leverage a low-code interface and more than 300 data and AI-based transformations, letting you transform data more easily and with more flexibility than any other tool. So what is a data flow in a nutshell? Data flows are a type of cloud-based ETL, and ETL stands for Extract, Transform, Load, tool for building and executing scalable data transformation processes. Dataflows Gen 2 allow you to extract data from various sources, transform it using a wide range of transformation operations, and load it into a destination. Using Power Query Online also allows for a visual interface to perform all these tasks. The ability to specify an output destination along with enhanced compute time are what set Dataflows Gen 2 apart from their predecessor. Dataflows allow you to promote reusable ETL logic that prevents the need to create more connections to your data source. Dataflows offer a wide variety of transformations and can be run manually on a refresh schedule or as a part of a data pipeline orchestration. Let's recap the main differences and main characteristics of Dataflows Gen 2 and pipelines. Dataflows Gen 2 should be used whenever you need to implement more complex data transformation operations. Then, for data profiling, Dataflows Gen 2 provide a built-in set of features to allow quick and easy data profiling options. It also provides a familiar Power Query experience, so if you are transitioning from Power BI world, you will find yourself in very familiar environment. Last but not least, Dataflows Gen 2 offer more than 150 connectors out of the box, meaning there is literally almost no data source out there that cannot be leveraged from Dataflows Gen 2 out of the box. On the other side, pipelines' main purpose is for data orchestration. Using copy data activity, you can apply some simple lightweight transformation like changing column data type or removing unnecessary columns. But with pipelines, your transformation capabilities are pretty much limited. Again, Dataflows Gen 2 can be implemented as part of the orchestration process and one of the activities in the pipeline. Let's move on to the next component, which is real-time intelligence. Within real-time intelligence, we have at least 5 important items to understand: Event House, KQL database, KQL query set, event stream, and activator. Before we proceed to explain each of these items in more detail, please keep in mind that the main goal of using real-time intelligence in Fabric is to handle streaming data, data in motion, meaning as soon as data arrives, you want this data processed and stored within the Fabric. Now let's start with the Event House. The Event House represents a container for KQL databases. The main purpose of the Event House is to provide a unified monitoring and management across all KQL databases. Keep in mind that as soon as you load the data in a KQL database, it's automatically indexed and partitioned to support quick and performant queries over data coming from your IoT devices, time series data, and similar. KQL databases exist in the context of the Event House. This is a Fabric workspace which contains Event House A and Event House B. Each of these event houses may contain one or more KQL databases. KQL query set represents a collection of one or more KQL queries. The main purpose of creating a KQL query set is to ease the process of sharing queries with others. If you are coming from a SQL background, You might be wondering, can I use SQL to query the data in the KQL database? The short answer is yes, you can, but you should leverage the power of KQL language and translate your SQL skills into KQL statements. By using explain command, you can convert existing SQL to KQL command. As we already mentioned, you can write T-SQL, but then you are missing the point and you will restrict yourself from leveraging multiple useful functions of KQL language that are specifically built to work with time series and telemetry data. Event Streams feature in Microsoft Fabric gives you a centralized place in the Fabric platform to capture, transform and route real-time events to various destinations with a no-code experience. The event stream item you create in the portal is an instance of Fabric event streams. When you create an event stream, you add event data sources, routing destinations, and the event processor when you need the transformation. It allows you to apply no-code transformations on the fly to your data, such as filtering, managing fields, aggregating data, group by, joining, and many more. This is a typical workflow within the event stream. You connect to one of the supported data sources, and you can see currently supported data sources on the left-hand side. Then optionally you perform data transformation on the fly, and finally you can load transform data into one of the supported destinations, namely Event House, Lakehouse, Derived Stream, Custom Endpoint, or Fabric Activator. Let's spend some time trying to explain the Activator experience. It's a no-code experience for automatically taking actions when certain conditions in your data are met. Activator monitors data in Power BI reports and event streams, and if the condition is met, it will trigger a certain action. Action can be sending an email through Outlook or sending a message through Microsoft Teams, all the way to triggering Power Automate flows. There are three main concepts within the Activator that you should be aware of. An event is an observation about the state of an object, with some identifier for the object itself, a timestamp, and the values for fields you are monitoring. Objects that you want to monitor could be physical objects like freezers, vehicles, packages, and so on. The business object can also be an abstract concept like advertising campaigns, accounts, and user sessions. Rules define the conditions you want to detect on your objects and the actions that you want to take when those conditions are met. This is a high-level overview of the real-time intelligence workflow in Microsoft Fabric. Starting from the left-hand side, we have different data sources. From there, establishing the event stream, we can ingest and process the data coming from these data sources, analyze and transform on the fly, and depending if you want to act immediately, we can use reflex item, or we can store the data in the event house. From there, data can be either queried using KQL query set or visualized, again, either using real-time dashboards or Microsoft Power BI. Let's now talk about the latest component introduced in Microsoft Fabric, and its databases. Currently, this experience includes only one item, and this is SQL database in Fabric. Now, first, let's demystify what SQL database in Fabric is. That is a software as a service operational database. If we take a short tour through the evolution of SQL solutions in cloud, let's start from the left-hand side, where SQL Server on Azure Virtual Machine is offered as an infrastructure as a service solution. Then we have two platform as a service offerings, Azure SQL Managed Instance and Azure SQL Database. With SQL Database in Fabric as a first software as a service fully managed transactional database, we finally have this missing piece of the puzzle when it comes to dealing with transactional data. When you create a SQL database in Fabric item in your Fabric workspace, there are certain things to keep in mind. First of all, the main item is SQL database. This is an operational database based on Azure SQL DB that already exists outside of Fabric. Because it's based on traditional Azure SQL DB, it supports all traditional T-SQL workloads. However, it's not possible to write cross-database queries with other Fabric items directly from the SQL database item. For that, we need to use a SQL Analytics endpoint. Now the fair question is, what SQL Analytics endpoint represent? It represents a data mirrored in near real time to delta parquet format. And since the data is mirrored to delta parquet format, it can be leveraged and combined with other Fabric items, so cross-database queries are supported from the SQL Analytics endpoint. However, keep in mind that no write operations are supported through the SQL Analytics endpoint. It's just a read-only version of the data stored in SQL database. The next component we are going to examine is the biggest one in Fabric. It's called Analytics. So let's first examine what belongs to Analytics. There are three different workloads in Analytics: data engineering, data warehouse, and data science. So let's kick it off by understanding the characteristics of two houses in Fabric: data lakehouse and data warehouse. Data lakehouse represents a scalable, distributed file storage system, which is suitable for storing all types of data, such as unstructured, semi-structured, and structured data. It allows for flexible schema-on-read semantics. On the other hand, data warehouse more reminds of traditional data warehousing workloads. It supports relational schema modeling, SQL-based querying, and it's suitable for storing structured data. Now first, let's examine the lakehouse. The creation of a single lakehouse produces three individual items in the Fabric-enabled workspace. Lakehouse itself is the lakehouse storage and metadata, where you interact with files, folders, and table data. You should be aware of two different areas within a lakehouse: files and tables. Files represent unmanaged area. When we say unmanaged, this means this area is not managed by Spark Engine. In files area, you can store literally any file format, such as video, audio, photos, JSON, CSVs, and so on. Tables area represent the managed area of the lakehouse. It's managed by the Spark Engine. And in this area, you should store your data preferably in Delta format. The SQL Analytics endpoint is a read-only point to which you can connect and query the data with T-SQL language. Keep in mind that only Delta format tables from the lakehouse are exposed through the SQL endpoint. This one is needed for direct query fallback behavior that we are going to examine later in this video. Finally, a default semantic model is an automatically created data model based on the tables in the lakehouse. Power BI reports can be built on top of this semantic model. After loading data into lakehouse, you can use various tools and techniques to explore and transform it. So let's briefly examine some of them. Apache Spark. Each Fabric lakehouse can use Spark pools through notebooks or Spark job definitions to process data in files and tables in the lakehouse using Scala, PySpark, or Spark SQL language. Notebooks represent interactive coding interface in which you can use code to read, transform, and write data directly to the lakehouse as tables or files. Spark job definitions are on-demand or scheduled scripts that use the Spark engine to process data in the lakehouse. SQL Analytics endpoint. As we already mentioned, each lakehouse includes a SQL Analytics endpoint, through which you can run T-SQL statements to query, filter, aggregate, and otherwise explore data in lakehouse tables. Data Flows Gen 2 can be used to ingest the data into the lakehouse, but you can also create a data flow to perform subsequent transformations through Power Query experience and optionally land transform data back to the lakehouse. Data Pipelines, which serves the purpose of orchestrating complex data transformation logic that operates on data in the lakehouse through a sequence of activities. Finally, we can visualize the data with good old Power BI. If you ask me, notebooks are one of the coolest items in Microsoft Fabric. So first, let's discuss what Fabric notebooks offer over the other ingestion options. By default, Fabric notebooks use PySpark language, which uses the Spark engine to allow in a multi-threaded distributing transaction for speedy processing. You can also use other languages such as Scala, Spark SQL, R, Python in your Fabric notebooks. Next, notebooks allow for writing comments using the Markdown feature, which significantly increases the value of the entire code writing process. In addition, you may also run or freeze individual or multiple cells within the notebook. Fabric notebooks can be easily created in many parts of the Fabric platform. Unlike manual uploads, notebooks provide automation, ensuring a smooth and systematic approach. Let's now explore Warehouse item in Fabric. So Warehouse is also centered and built around a single data lake, which is OneLake, and it's powered by Synapse Analytics, or to be more specific, by the engine called Polaris, which was introduced in Azure Synapse Analytics. When it comes to T-SQL support, we can say that it fully or almost fully supports all T-SQL functionalities. Finally, keep in mind that once you store the data within the warehouse, it's still Parquet file format in the background. So just to make clear and wrap up this story about the lakehouses and warehouses, essentially in the background of both lakehouse and warehouse is OneLake as a central storage repository, and Delta format as a chosen format for storing the data. The only difference comes from the processing part. Whereas you will use Spark engine and notebooks to process the data in a lakehouse, you will use a T-SQL engine and T-SQL statements to process the data stored in a warehouse. But from a pure storage perspective, in both cases, it's just a Delta Parquet file. And looking from a storage layer, there is no difference between lakehouse and warehouse. Data science experience enables users to create complete data science workflows and achieve the goal of data enrichment and discover additional business insights. It covers all the stages of the data science workflow, starting with the data exploration through the data preparation and cleansing, all the way to building experiments, models, model scoring, and providing predictive insights in business report. Fabric provides a whole range of different tools to implement a successful data science project. For example, for the data exploration phase, you may use Fabric notebooks, which we've already examined. Then for data preparation, users can leverage Apache Spark and Python with its extensive set of libraries. For data cleansing, there is a special tool or feature called Data Wrangler. You may think of it as a Power Query editor for Python and data science tasks. There is a variety of dedicated libraries for creating experiments and machine learning modeling. MLflow experiments can track machine learning model training. Microsoft Fabric provides a built-in MLflow experience where users can log experiments and models. Finally, the open source Synapse ML library immensely simplifies the process of creating machine learning pipelines. Once you have predicted values stored within OneLake, this data may be consumed via Power BI reports, which makes a very convenient way for data science practitioners to visualize results of their model trainings and tests. Another quite interesting feature in Fabric is called Semantic Link. In simple words, it allows connecting to semantic models in the Fabric workspace and then performing a whole set of different tasks on top of these semantic models. A few basic examples would be: you can get the information about semantic models such as columns, measures, relationships, and so on, or you can run DAX queries against semantic models directly from the Fabric notebook. And many more, of course. Keep an eye on this feature, it's really powerful and opens a whole world of new possibilities. Fine, let's move on and understand how Power BI evolved through Fabric. So to reiterate, the current Power BI architecture, the architecture before Fabric, the most common way of dealing with Power BI implementation and the recommended way of doing things is import mode. This is a typical workflow when using import mode. You import the data into the instance of the analysis services tabular, that's the cube in the middle, and from there, Power BI reports are sending DAX queries to populate visuals in your reports. Whenever you need fresh data in your semantic model, you need to go back to the data source and refresh the data stored in the analysis services instance. This approach has its greatest benefit in providing a blazing fast performance, because data is stored in memory. On the flip side, the most obvious downsides are data duplication, because you are basically creating a copy of the data from the data source, as well as data latency, since in order to have the latest data from the source available, you need to refresh the semantic model. Direct query mode solves these shortcomings, namely data duplication and data latency, since no data is moved from the original data source and your users will always have the latest data available, because the data is retrieved at the query time. However, and I'm sure all of you who use direct query mode at least once, will agree that performance is, well, significantly worse than with import mode. Let's put it that way. And here is where Direct Lake mode enters the stage, trying to exploit benefits and overcome the downsides of both import and direct query modes. In a nutshell, it's a hybrid of import and direct query. There is no data duplication and data latency, since Power BI will read the data stored in the OneLake Delta files directly, but this time with the performance of the import mode, or let's say very close to the import mode, because the data is stored in the same way as in the proprietary format of analysis services, which is suitable for fast data retrieval. If you ask me, Direct Lake is really something brand new in the data world, let alone in Power BI. Therefore, I honestly consider this feature revolutionary. And let me quickly explain why. Before I show you how Direct Lake works and why it is so special, let's first understand what are the prerequisites for using it. First and most important, you need either Fabric F capacity, no matter the size and power, or Power BI Premium capacity with Fabric Workspace enabled. Then you need a Fabric Lakehouse with a SQL endpoint that we previously examined, which is necessary because in case your queries can't be retrieved by using a Direct Lake mode, they will fall back to a well-known Direct Query mode. Direct Lake works for both Fabric Lakehouse and Warehouse. Next, data must be stored in Delta tables. So if your data is in other format than Delta, such as Parquet or CSV or JSON, no Direct Lake queries are possible. Finally, V-ordering. This one is not a hard prerequisite, that's why I put this asterisk, meaning that Direct Lake would still work, even if Delta files are not V-ordered, but you should then expect performance degradation. Now you're probably wondering, what on earth is V-ordering? Don't worry, I won't bother you with heavy technical details. Simply said, it's a Fabric-specific way of additionally optimizing Parquet files when writing data. Keep in mind that all Fabric engines by default will write files using V-ordering. In this demo, I want to show you how easy and quick you can create a Direct Lake semantic model on top of the data stored within the Lakehouse. Don't forget, by default you get this default semantic model provisioned out of the box once you create a Lakehouse, but this one has a pretty limited set of features and capabilities. Hence, you probably want to create your own custom semantic model in Direct Lake mode. I'll open a Lakehouse, and then in the top ribbon I'll choose the option New Semantic Model. This will open a dialog window, and let's call this one Ultimate Guide Fabric. I'll store it in the same workspace, but as you see, you can choose between different workspaces that exist under this Fabric capacity. And then let's select all the tables that we want to include in this semantic model. So I'll choose dim customer, dim date, dim product, and fact internet sales. Those 4 tables will be part of my Direct Lake semantic model. Once it's done, you see all the tables that are part of the model, and now we can establish relationships and create a proper model as a star schema. So I'll go and create my relationships between the order date and full date alternate key. That's the first relationship. Then I'm going to create a relationship between product key in my fact table and product key in my dim product table. And finally, let's do the same thing for customer. So customer key and customer key. We can also manage relationships, create row level security rules, and all the other things that we could do with regular import semantic models in Power BI, except creating DAX calculated columns and DAX calculated tables. This is still not supported in Direct Lake storage mode. Also, we can create a measure, so let's create a very simple measure for a sales amount, which will equal the sum of the sales amount. From here, let's go and create a new report using the Direct Lake storage mode. So let's put sales amount, and let's put, for example, something from dim product, such as color, let's say. This is how easy and straightforward it is to set up your Direct Lake Power BI semantic models. Fine, I'm sure you love Fabric, there is no doubt about that. But at the end of the day, it's not just about love. I hope you watched the famous movie Jerry Maguire. And there is a great scene when Cuba Gooding Jr. asks Tom Cruise to scream loudly on the phone, "Show me the money, show me the money!" And that's exactly what Microsoft will ask you to do. So I'm sure you stayed so long with me today in this video to hear how much this new thingy will cost you. First and most important, there are two available pricing models with Microsoft Fabric. Here on the left hand side, you will see the pricing list of the pay-as-you-go model, as of today in the West Europe region. Always make sure to check the specific prices in your region. On the right hand side, you see the option for reserved instance pricing or capacity reservation model. Now we come to the more interesting part, especially if you are a larger shop and or prefer to have predictable monthly costs for Fabric. Similar to the Power BI premium per capacity licensing model, you can reserve resources and lock the price on a monthly basis for a period of 1 year. The current prices, if purchased via an Azure subscription, are slightly higher than if paying via M365 subscription. On the other hand, current F capacity based prices are significantly lower than pay-as-you-go model, approximately 40%, so that may be a good incentive to choose this model. It's not over yet. Don't forget that storage and compute layers are completely separated in Fabric. So this pricing was for compute, but you also need to calculate storage costs, which currently sit at $0.024 per gigabyte, or approximately $24 per terabyte of data. Now, we live in the era of AI, and the Copilot is now a buzzword. So I'm sure most of you are interested to hear how Copilot works in Fabric. So Copilot is currently available only for F64 and higher Fabric capacities. Meaning if you buy, for example, F8 or F16 capacity, no Copilots are available. These are my go-to resources to proceed from this video. First of all, I firmly believe in learning by doing, so I encourage you to set up your Fabric trial account and try it for 60 days for free. The link to activate trial capacity with all the instructions is included in the video description, as well as Microsoft Fabric official documentation, which is quite comprehensive and really covers all the detail about each component of the platform. I sincerely hope you enjoyed this video. If that was the case, please make sure to click this like button down below. Also, I plan to do a separate video and deep dive for every single Fabric experience in the future. So make sure to subscribe to Data Mozart YouTube channel. See you soon!